Hi, welcome to part 2 of module 1. And so let's get started talking about everything after the law of conservation of energy. So energy supply is a key limiting factor to economic growth in any part of the world. And a lot of times what makes a nation great is their ability to consume and supply energy. And so it's important. One of the biggest things that made America great was the sheer amount of resources. Resources are a form of energy. And so we had it, other places didn't. It helped make us an excellent trading partner, and it's part of the backbone of what gave the United States its power. So, looking a little bit about energy consumption in the United States from 1776 to 2015. And anytime I supply data to update something that was in the book but is out of date, for example, the one in the book is from 2008. I wanted to go farther because I knew the data was more current. And so this one goes up to 2015. I will tell you where I'm getting my information from. So, if you look at the very bottom of the screen, you can actually see that I got this from the Energy Information Administration, or the EIA. And so I'll always give you my data sources. I want you to know that we're talking real information, real measurements. We're not making up stuff. This is science. It's got something to measure itself on. So here we go. Looking at the information, you can see they're talking about quadrillion BTUs, and a BTU is a British thermal unit. And one BTU, or one British thermal unit, is about the amount of energy that would have been given off by a matchstick. Like one of those really good matchsticks that have the nice stick part that you can light and burn for a while. And about that amount of energy of heat and light is equal to 1 BTU, so that you're given an average amount. We're talking about quadrillions of BTUs. And so petroleum has dropped, and it just hit a new peak. It's rising back up, and it's being consumed at about 35 quadrillion BTUs in its set of current time. And you can see natural gas has been in an all-time high, and it's just been one of those resources that has been growing as a market. And so natural gas is at an all-time high of use. Coal is on a dropping use and has been on a dropping use. It's been in a decline since the 1970s on. Nuclear energy has been stagnant, and the reason for that is we have not done anything with nuclear energy since the 1970s. And we'll talk more about that when we hit the nuclear topic in this course. But you can see it's stayed kind of steady state. The amount of energy that nuclear facilities are producing is been about the same. Biomass is seeing an all-new high, and biomass is anything that we can use that's made out of living materials that we could burn or utilize. So burning wood is biomass, as well as the biodiesels and all these natural fuels that we're coming up with. They're there. Hydroelectric has been steady state since the 1960s. A lot of our dam projects were built around 1960 before. And so everything after that point got a little bit difficult to build and create really big international growth. And so stayed steady state from the 1960s on. And you can see that on the graphic below. And the final one is other renewables. And other renewables include everything from wind to solar. And so we've got wind, wave, solar, you name it, it's in there. So all the other renewable things that you can think of are under that other renewable title. The United States has the highest per capita energy consumption. Every person in the United States consumes about what's worth of 7 gallons of oil per day. And this is about 5 times the world average. The world average is about 1.4 gallons per day. But keep in mind that that's a world average. So we're not comparing ourselves directly to someone, for example, in Great Britain, who has a very even consumption rate with us, as composed to somebody who's in Africa, in a third world country, which has a consumption rate well under a gallon of oil per day, if we were to equate all the world's energy into gallons of oil. To create that into a graphic view, here is the graphic version of the amount of energy use based on quadrillions of BTUs, so using the same units again, and you can see we're pretty big, but this doesn't show the whole story. In order to get the whole story of how much energy consumption we get compared to the rest of the world, we really have to compare it to the amount of population. We do have a lot more people than a place like England or France or Canada. But India has a lot more than us, and they're only at 17.7 a quadrillion BTUs. So this is a much better graphic. And once again, the information of where I got that is down below. And so you can see that in the United States, we make up about 5%. It's 4.6% of the world population. We consume about 25.4% of the world's energy consumption. Compare that to some of the highest populations part of Asia down below, which they're not taking into parts of the Russian regions. They're taking in kind of the Asian, East Asian, and they added Australia in there because Australia is like a little blip of energy consumption. And you can see that they make up 55% of the world's population, and they use about 20% of the world's oil. So it's pretty significant how lucky we are in the United States and how much of the world energy pie we get to have. It's a lot more than other parts of the world. And we have to remember that as our ability to consume oil and our economic worth becomes more even with the rest of the world, our ability to receive and have is going to drop. And so we're very privileged at this time, but something has to change. And two things can kind of take place to create this change. One can be us advancing our technologies so that we become more sustainable, so that we can continue to live comfortably. The other one is to change the way that we're living and actually have less. And the truth is, the answer is probably going to happen somewhere in between. And that's because I'm an optimistic person. I don't want to pretend that the world is going to be doom and gloom. But at the same time, I don't think we're going to answer everything with technologies. And so the answer will lie nuanced in between the two, but that's where it can go. This is another view of that same map, but this time we're talking about world energy consumption based on sources. And so when we take into account the amount of fossil fuels, we understand why oil is so important to the world, why wars can and will be fought over oil. It's because it's 80% of our energy need. 80% of what we're using to run the world, to make the world go. 2.7% is nuclear, and then that little slice of pie that's in the green is all renewables, all renewables. And then they break up those renewables into other pieces. And so if we take the little pie over from the green slice over to the big solid slice, we can see what it breaks up into. And we can see that there's biomass heat, and that's the big, big, big cut, and then everything else is tiny. Once again, biomass heat is burning of living or once living things. So it can be wood, it can be pieces of material, it can be garbage. Garbage burning is technically biomass. So it's not like a nuanced, funky biodiesel, ethanol, corn, sugar cane, funky thing. It can be something really conventional, like I took garbage and I burned it and I used that heat to turn a steam turbine, which made energy for me. So we have to keep in mind that that's a big housing too, right, in the statement of biomass. And then the other big one, as we can see here, is hydro. Hydropower makes up another big piece of that chunk. And hydropower is growing. So this is a 2010 source model, which means that it includes the building of Three Gorges Dam, which is the largest dam in the world. It consists of three gorges, and it's in China on the Yangtze River. And we're actually going to do a case study on Three Gorges Dam in the Yangtze because it is the largest in the world. We'll also talk about our own largest in the United States. Our biggest dam is Hoover. We'll talk a little bit about its size and its capacity in this course. The last graphic I'm going to show you is energy use and consumption based on fuel and fuel shares, and you can see it's the same breakdown of that material. So this gives us a little piece of information on the coursework as it stands currently, and I will pick up with one more video, which is my part 3 for Module 1.